Hello, welcome back. We're here for another session of the week 2 topics. Picking up from where we left off last time. So we were looking at, we're starting to look at binary and hex. So at the end here, we were hitting the point where we had these 4-digit binary and then the hex equivalent. So in the past, people have talked about whether we need to memorize these or not, and you don't. We'll get into more conversion examples and you'll be able to see how you can derive these, and you just start from 0 going up to F and what that means here, right? So you have 0, 0, 0 all the way through, and let's say this is a 1, so this is a 1 here in binary, and we say 2, you have a 1 and the 2 place here, and a 0, that's how you get the 2. We'll go more into that, so you don't have to worry about it right now. But the key point I just want to emphasize, especially when we start going to the ASCII stuff, you'll be getting the mappings for these, and you could easily look up the mappings for these, so it's not a big deal. So we're just trying to explain why you have these mappings. If you had to derive these mappings on your own, let's say the binary to hex, you can calculate that. Okay, so let's move forward. So let's say we had to think about how to represent in zeros and ones our English language, Roman alphabet, let's say. So you can think about, we have 26 characters in the alphabet. We have uppercase, lowercase. We have numerals, which would be 0 to 9. You have punctuation characters, some common arithmetic characters. You also have a couple of miscellaneous characters, new line, tab, and backspace. So that accounts for like 95 symbols that you need to represent. So if we look here, ASCII, this is what ASCII stands for, American Standard Code, Information Interchange, right? So a standard, just like most other standards, is something that the various stakeholders can use to communicate back and forth in a common way. And so we're talking now about the language of computers. So how do we represent this in a way that's efficient for computers, understanding that computers communicate in binary, zeros and ones. Okay, so this is how we start with the idea of converting to something that is machine readable in a standard way. Okay, so based on the prior slide where we talked about how many symbols that we need, you come to this. So the initial stab at this with ASCII was 2 to the 8th bits, which would represent 256 symbols. And I'll show you how we get to that a little bit later. So as it says, the Latin alphabet. Okay, and then something is pretty standard. You probably get some reference to it later. It's just to understand that 8-bit sequence is equal to a byte. Okay. And here, it just shows a mapping table, right? So, oops, let me go back to here. It just shows the mapping table, right? So here's decimal, here's hex, here's octal, here's the character as you would know in red, right? So you can see A, B, C all the way through, and you'll see a reference here like mapping to ASCII 65 starts off with A, right? And you take that all the way through. You also have HTML over here, you have octal over here. So pretty much all you need to care about is over here, this mapping, and then later on we'll go more into how you convert into binary. Okay, but very quickly, you can see here we have basically a snippet of the prior ASCII table. Okay, so if you look at the top, you see human readable, so it says hello. Okay, and let me just, for example, go over here to the left with this. So let me take the O from hello. That equals to 4F in hex. So let's see. We see O, and then we move over here to the hex, and you can see 4F. Right, so that's how you get the 4F here. Okay, and then you think about, okay, well, how do we convert over here to machine language, right? So let me just take this down to here. You see the 4F, it goes to this red over here, okay? So you can see F equals to this 111, and this 4 equals to this. And you'll see this more clearly when I walk you through how to do conversions. But basically you can trace it all the way down from this O to the 4F to this string here of zeros and ones, okay? Like I said, I'll show you more how we get to that binary in a second. So as we mentioned before, the ASCII covers 256, okay? But then later on, I think people figured out that you actually need more than that. So then you get into Unicode, right? So Unicode, you have much longer string. You have 32 bits to code up the character. And then you have this idea of UTF-8, okay? So that's just a grouping of it. And when you get into HTML8, HTML, you'll see that you'll have this UTF-8 reference here. Okay, so this is like that binary to hex to decimal conversion table, right? Again, no one's going to ask you to memorize all of this, but I'll walk you through conversion so you can see how we get to that. You remember on that last screen where I told you have the F that maps to 111. You remember, I'll go back to here. You can see the F that maps to 111. So you can see how that plays out here. Okay, 111. So hex F 111 is the binary representation. Okay, and likewise, if you remember, you had a 4, so it was a 4F, 4 and an F. You can see the 4 maps to 0, 1, 0, 0. Okay, and this is where we get into some conversions. All right, so if you remember early on in one of the other lectures, we showed basically how things grew exponentially in terms of the numbers of symbols you can represent under base 2. Right, so this is 2 to 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is to the 8th, and so on, all the way until you got to 128. Okay, so I'm going to show I think the easiest way for me to show this to all of you is to show you on a spreadsheet, which I'll kind of whip up for you in a second. Maybe I can kill 2 birds with 1 stone because we're going to be doing spreadsheets later in the semester also. So you have 2, 0 all the way up to here, and you can represent 128. Okay, so every time I have a 1 here, I can drag it down, and it just represents this number, right? So if I have a 1 in this slot, that means I'm using this number. If I have a 1 in this slot, I'm using that number. And if I take all of that and add them together, you'll end up with 231. Okay, so let me come over here to a spreadsheet and try to demonstrate this to you. So I'm going to just very quickly set up 2 2s here. So because we're talking about base 2s here, okay, and let me do 6. Okay, and let me see here. If I want to do equals base 2, and then I'm going to put in a little caret sign, which is on my keyboard is the 6, number 6, little caret sign, and then I'm going to reference this cell here for 7, and you get 128. So Excel makes that calculation for you. Okay, and then I'm going to just copy it over to this one, right? And it's going to know to update the cell reference. Okay, again, you don't need to know how I did that. We'll have an Excel session later in the semester. But Let's see if I do this, and I drag this over. Excel knows to copy that over for me. Okay, and likewise, if I take this and I drag this over, Excel knows how to take those columns down for me, take those numbers down for me. Yeah. Put the 0 in here. And let me just drag this over. Okay. I'm going to drag this guy over here. Keep on missing this guy here. Okay. Alright, so what is it showing? This is your base. This is your exponent. And then this is your base to your exponent. Just open this up here. And let me see here. We got 1, 1, 1, 0, 1, 1, 1. Okay? So let me push this number here. 1, 1, 0, 0, 1, 1. Okay? So this just lines up with each of these guys here. Okay? Now all I'm going to do is take the equal sign, this one, multiply by this one. Okay? So another calculation here. And takes that out. So every time there's a 1 in this slot, this is the binary. So every time there's a 1 in this slot, it's going to multiply by 2 to whatever power it is, and you'll get a result here. So obviously, if you have a 0 here, that becomes a 0 down here. And so all I do is I do a sum of all of those. You get 231, okay, which matches up to here. Okay, 231. So I wanted to put this into an Excel spreadsheet so you can kind of see clearly the mechanics of how this works. So this is the mechanics of how you would take a binary number here. Let me bold this. And, oops, I spelled binary wrong. So how you would convert the binary to a decimal. Right, so that's my converted number here. Converted to decimal. Okay. So if you follow along with this, this is basically what you would be doing if you were trying to convert binary to decimal. Okay. Now, if you wanted to think about this in reverse, which would basically be taking your decimal number and converting it to binary, basically you just take what's the biggest number, right, and then see which slot that would fill in. So let's take this 231. So if I took equals 231 divided by 2, let's see here. So the biggest number, actually I didn't want to do it that way. Basically, if I look at these biggest numbers here, okay, what's the biggest number that will fit into 231? Okay, and then you divide and take the remainder. Okay, so 128 is the biggest number here. Okay, so 128 lines up with this slot, so that's how you would get a 1 here. Okay, so if I do a mod equals mod 231, oops, what did I do? Equals mod to do a mod here. Here we go. Okay, mod 10.3. All right. So let's see here. Equals mod. Here we go. 231 and 128. Okay, so that leaves us with 103. Okay, so 103 is remaining, and the biggest number out of these remaining that will fit into 103 is 64, right? So that means I'm going to put a 1 here, and now I'm going to do equals mod of the 103 and 64. That gives us 39, right? So 39, the biggest number is 32, so I will put a 1 here. Okay, let's continue doing this. Mod 39, and then I put the 32. That gives us 7. All right, now if I try to, for example, I look at 16, 16 is not going to go into this, so that should be a 0. Likewise, 8 is not going to go into 7, so that should also be 0. But 4 does go into this, so that should be a 1. Okay, so I hope people are starting to see the pattern here of how we're doing this, right? So you look for the biggest number that goes into this, and then you take the mod or the remainder, and then look for the next biggest number. Okay, so I'm doing equals mod, and in this case, we had a 4 that went in there before. Now we have 3. So this is fine. So 2 goes into 3. That's fine, right? And then we got mod 3, 2. We're down to 1. Okay, so you see 1 goes into it without a problem, and you have a remainder of 0, so you're done. Just like so, right? And that's how you get back to this binary from your 231, from your converted number. Okay, so I hope walking it through with this Excel sheet kind of gave you a good example of how to convert binary to decimal and back and forth. Okay, I'm going to save this into my resources so you can have a working example, but there's many of these type of examples that people are going to have for you on the internet. If you look at resources in the book or in our resources for week 2, you'll see the same thing. So if I'm here, then you'll see a whole bunch of videos here, right? So you got the ASCII, you got the data in bits, basically explaining binary in bits, and then you have these binary conversions, binary and hex conversions. So just go ahead and try all of that. Let me see here. Just drag this over a little bit. Okay. So where are we? We're here. Right, so this just goes into some more conversions here. This is trying to explain what I explained before in the Excel spreadsheet, where you have the ones and zeros multiplied by 2 to whatever exponent. Right, you can take that all the way through. Similar concept applies on hex, actually. And then this basically talks about doing the whole division and what kind of remainder you get here. So you have 72, you have the 36 with the remainder of 0, and it builds it up that way. Okay, so it's a little bit different than the way I just showed you, but it's along the same principles. Okay. So it keeps on dividing by whatever you have left over here. So in this case, pretend you had that 231 I went over before. You divide it by 2, you get this number here, and then you take it over to here and divide it. And then you just build up based on these remainders here. So you guys can choose whichever one you feel comfortable with. Play around with it. I think the easiest thing to do is play around with it on an Excel spreadsheet. And you can take it through and see which one helps you to understand this concept better. Okay. I know you guys are gonna get a whole bunch of practice on this, but if you'd like to submit for some extra credit, you can go ahead and try to fill in these different grids here based on these numbers. Okay, so if you can copy and paste this into wherever, like an Excel spreadsheet, do some of the calculations and just kind of show the steps that you did it. I'm not really going to care too much about the actual answer, just more that you can show me that you're following the right process. I think that's all you need to do. You'll be doing a whole bunch of practice with this. Like I said, it's very important. It's going to be covered in the exam, and you will have to show your work. So it's not just like you punch in a number and magically you have a new number here. You have to show the logic that you use or the process that you use to convert to each of these other numbers. So you're going to be guaranteed to have this on your quizzes and exams. So make sure you practice this. If you want to submit it for extra credit for me, go ahead and fill this in for me. Okay. And for the one-on-one sessions, if you're still having problems with the mechanics of going back and forth between hex and binary, decimal, ASCII, whatever, let the TAs know, let myself know. The TAs should be covering this with you and the recitations also. But if you still have problems, just let me know and we'll work on it together. And there's also a lot of resources on the internet to work with you on this too. But it is an important topic, so do make sure you got the mechanics of it, the understanding of it. So the last bit for this lecture is talking about metadata. Okay, so what is metadata? Basically, it's data about data. Okay, so you'll hear this all the time whenever someone talks about metadata. So it's data about data. So you can imagine there's a couple of different scenarios for this. But let's say I have a Word document, right? So the Word document, you have a whole bunch of content in there. You're writing about a particular topic. It's written by somebody. When was it created? There's could be other things in there about like the edits that were done in there, the formats and whatnot. So all that would be encompassed in metadata. If you look at like a web page, although that's something that's constantly changing, but search engines will be looking at metadata to help it understand how relevant the content there is to whatever you're searching for. So there's different ways to slice and dice and understand the metadata. So for a web page, so you will be tagging it on different things. Maybe you would tag a web page that you're talking about a class at Rutgers. Who is it taught by? What type of topics does it cover? So you'd be tagging it. And so all that would be like metadata. And that would help a search engine if you're trying to search for a page about a particular class, a particular topic. But metadata could be for all kinds of stuff, right? It could be for like a spreadsheet, it could be a Word document, whatever. And it's just really helping other people to understand more about that. And with all of the wealth of information that's out there, metadata helps people to quickly find what's relevant for what they're looking for. As an example of why you might use metadata, okay? So these kind of give some example, right? This one's talking about the content, the structure of the content. Let's say the units, right? So maybe you have a whole bunch of like information with numbers and whatnot. What type of units, maybe what type of currency, something like that. And when was it created? You can imagine it's all kinds of information that you can put on there, and it's useful for other people without having other prior knowledge of the content. Here, so this just kind of recaps everything. I'm going to just pop through a couple of these different things. I think we've hit on all of the different things from the PowerPoint perspective, and I'll post this PowerPoint to my resources along with the spreadsheet example that I did before. Let me come back to the resources page here. Yeah, so you got the book, which is fine. So learning objectives, digital, analog information. Remember digital information, 0 and 1, or some discrete points. It just happens most of the time we're working with 0 and 1. Analog information would basically be shades of gray, something in between 0 and 1, or these discrete points, usually to something like infinity, right? The conversions, this is base 2, 10, and 16. You have the ASCII coding, unicode over ASCII, number of bits to represent certain symbol ranges, right? So if I need to represent 100 symbols, how many bits do I need? If I had to represent 400 symbols, 500 symbols, how many bits do I need? You should be able to figure that out. And you can look at multiplying, dividing binary by powers of 2, which is what I did for you on the spreadsheet. Okay, and we'll have this part here in the upcoming lecture. Okay, so this is chapter 8. So I've only covered this part up here so far. Okay, I mentioned this before, so take a look at all of these videos here. And some of this vocabulary will be picked up in the chapter 8 lectures. I didn't get to those yet, but this part over here at the beginning I've covered already for chapter 7. And then you have the textbook questions. Like I said in one of my earlier clips, you don't have to give it to me or the TAs, but you could let us know if there's any questions that you don't understand, and I'm happy to go over that with you. Okay, this is just talking about stuff in the recitation. Again, more conversions, so you guys will get plenty of practice on how to do conversions. Okay, so that's it for now. I'll be getting to the next chapter's lecture soon. Okay, thank you.